For centuries, the idea of luxury has carried with it an implicit promise. Not just beauty, not just status, but endurance. A belief that what is expensive is, by its very nature, built to last. Hand-stitched leather, reinforced seams, materials sourced with care, shaped by skilled labor, and sold with the quiet assurance that they will outlive their cheaper counterparts. But in a modern world defined by mass production and branding, that assumption deserves scrutiny. Because durability is not a story told in advertisements. It is revealed through stress, through friction, through time. To understand whether luxury truly delivers on its promise, we must move beyond perception and into measurable reality. We must place high-end fashion items and low-cost alternatives into identical conditions, subject them to the same forces, and observe what remains when prestige is stripped away. The comparison begins with materials. Luxury goods often rely on natural inputs: full-grain calfskin, high-density cotton, wool fibers woven with precision. These materials are not just selected for appearance, but for structural integrity. Full-grain leather, for instance, retains the outermost layer of the hide, preserving its natural fiber strength. It resists tearing, adapts to stress, and develops patina rather than degradation. In contrast, budget alternatives frequently depend on synthetic substitutes: polyurethane coatings, bonded leather, polyester blends. These materials are engineered for cost efficiency and visual similarity, but their internal structure is fundamentally different. Instead of long, interwoven fibers, they rely on chemical bonds that weaken under repeated stress. At first glance, the difference is negligible. A synthetic handbag can mimic the sheen of leather. A low-cost jacket can replicate the silhouette of a tailored coat. But durability is not tested at a glance. It emerges over repeated use. When subjected to abrasion, constant rubbing against surfaces, the divergence becomes visible. Natural leather scuffs, but often retains its integrity. Minor damage can be absorbed into its surface, sometimes even enhancing its character. Synthetic materials, by contrast, tend to fail more abruptly. Coatings peel, surfaces crack. Once compromised, they rarely recover. The difference is not aesthetic, it is structural. Stitching provides another point of comparison. In luxury items, stitching is often performed with thicker threads, tighter spacing, and reinforced stress points. Areas subjected to frequent tension, handles, seams, and closures, are deliberately strengthened. The goal is not just assembly, but resilience. In mass-produced goods, stitching is optimized for speed. Automated processes favor efficiency over reinforcement. Thread density may be lower. Stress points are not always treated differently from low-impact areas. Under controlled stress, pulling, weight-bearing, repeated opening and closing, these differences accumulate. Seams in lower-cost items begin to loosen, threads fray. Structural integrity declines, not suddenly, but progressively. Luxury items, when properly constructed, resist this degradation longer. But even here, the picture is not absolute, because price does not always correlate perfectly with craftsmanship. In recent decades, the luxury market has expanded dramatically. Brands that once operated on limited production models now produce at scale. In some cases, manufacturing has been outsourced, materials altered, and processes streamlined to meet global demand. The result is a subtle but important shift. Luxury in certain segments becomes less about construction and more about perception. A brand name can command a premium even when the underlying materials and techniques do not fully justify it. This creates a spectrum. At one end, there are heritage products, items still made with traditional methods, where durability is a core design principle. At the other, there are branded goods that rely more heavily on marketing than on structural superiority. The same tension exists within the budget category. Not all inexpensive items are poorly made. Some achieve durability through clever engineering, efficient design, and material optimization. Advances in synthetic fibers